at the background of the slide, Ayman scar, of course, as a scale. And when we have seen these successions at the beginning, when we came to Kuwait, especially that these rocks are one of the main producers, reservoirs of Kuwait, which is Lower Fares, as it's known in KOC. But unfortunately, when we go and dig into a deep of how the publications are doing in this area in terms of the intensive studies, we found a different story, and that's what we are going to share with you today. So first of all, thanks for having us today. That's our pleasure. Ayman Amr and myself, Ali. We have extensive experience in Schlumberger as a geologist. Geologist means that we have done several job domains, from borehole to field scale to outcrop. Some of you, they know us, and some are not. So we are happy today to know the rest that we don't know. We will go through some, headlines or outlines that we hope by today to cover and give you some, flavor of what we have done in the area. We will start with what is the history and motivation of the geology field work that we have done. The field observation and measurements we have conducted in Jal Az-Zor. The sedimentology and exposed sequences that we have experimented, and what is the result of in terms of stratigraphy and Facies association and conceptual depositional setting. So as you can see on the picture, this is Ayman at the top as a scale. You can see that we have very good exposed rocks, like we are looking at in Utah. If we have taken an example, with taking into consideration the scale of the exposed rock in there.
So basically here, what you could see is a comparison between two different seismic sections taken from two different authors, 44 years apart from each other. So when we first looked at the Jal Az-Zor, and we realized, and everyone noticed, that the Jal Az-Zor is the largest outcrop in Kuwait. If you take a look at the publications done so far, most of them, as you could see here, describe it as fine sand, grain, and you could see there's an absence of the identification of what type of sediments are they, what type of depositional environment have these deposited in, and what type of setting is it. So in terms of the facies, this is where we felt there's a big gap, and this is where we wanted to step in and fill that gap. So by looking at several publications, and this is from a publication that we did on the age dating of the Jal Az-Zor outcrop, and as well as some well data as well, we have noticed, and as you can see here, there's a big discrepancy in the identification of what has been known as the Kuwait group. So here the Kuwait group is composed of the traditional tripart, which is generally undifferentiated in the most part, especially in Kuwait. So we have the Dibdiba, Lower Fares, Ghar. Mostly the age is identified as Miocene. However, if you take a look at the Lower Fares itself, sometimes it's middle Miocene, sometimes it's early Miocene, sometimes it extends from middle Miocene all the way to late Miocene, and Dibdiba as well, except for Salman, where he identified Ghar as occupying the Oligocene. The Oligocene in Kuwait is generally described as eroded or non-deposited. And this is where we have been looking at and focusing on. And just a question to answer here at the beginning of this presentation: what is the reality based on age dating results? So we will see by the end of the presentation, hopefully we will have some highlights on what do we think this looks like.
Okay, so Ayman, he has demonstrated the technical motivation of this field work. Yeah. Go ahead, Ayman.
Yes, absolutely. So basically, those are the motivations why we wanted to study the Jal Az-Zor outcrops, but also we wanted to study Jal Az-Zor outcrop because of our basically love to geology, our interest in geology. And I can tell you, if we didn't have love to what we are doing, we would have not reached to where we are at the present time. We have highlighted significantly the importance, the facies variations, and let me thank here all our group, Ali, Dr. Mubarak Al-Hajri, Faisal Qattan, Dr. Muhammad, and also Dr. Yaqub. So all of these members contributed to this work in a way, and all of the work that we have done was done also voluntary. So in some cases, we fund ourselves. We are a self-funded group to analyze in terms of the thin sections, in terms of the XRD and the analysis that Ali will highlight later on. But also we try to bring along the new generation of geologists. As you can see here, we have our children with us, and we are trying to teach them as well geology. So at least maybe one of them will have the passion and love for geology as we have. And this is one way from us to thank Kuwait and give back to the community by helping Kuwait understand the value of their outcrops. Because as Ali said, he gave an example from Utah. We have studied outcrops in different places and different locations. And what you have here in the bulk part can be summarized in textbook examples of various types of depositional facies that you should be proud of and you should market as well.
Great. So based on these motivations, we started with the technical motivations of having that not well described sedimentology of the exposed rock, then to our motivation of passion for geology and going outdoor activity. Behind the scene, there was also, Ayman, not to forget, too many barbecues in there. So we have done our objective and what we need to do out of this. So we need to do descriptive sedimentology, which is the basics of the basics that any geologist, when you go to a field outcrop and explore the area. And based on that, we want to go from the foundation, which is the sedimentology, to the upper scale, which is having a representative stratigraphic column of the area. And based on these two main pillars, we wanted to understand laterally and vertically how is that these sequences were deposited, and also to understand the architecture of these deposits. As at the end also, we were trying to identify how is the mechanism of this outcrop has been formed in terms of, is it structural or a larger scale of erosion, and also to define the age of these exposed successions. So if we can minimum identify one of these units as an age marker, we can unlock how is the puzzle of the age variance from the subsurface to the surface as well. So this work also will be in the benefit of the subsurface rocks that we are exploring in the area. Based on that, you can see that our work is simply classified into two main parts, which is the field work and the lab work. The field work is usually, when we go to the field, we focus on the measurements and sampling. We need to sample all the main facies variations within the area. Documentation and description. So even any note that we see in one of the locations that we have observed, it should be documented and described, and we can go back for that in details. The lab work was mainly for the samples that we have taken in terms of thin sections, XRD, XRF. We have some samples also have been tested by or experiment and examined by strontium and carbon isotopes. And the most important part, which is the office work, this is where all the team and even within the expertise inside and outside of Schlumberger, we gather with them, we integrate the data, and we do like brainstorming all the time. By the way, this work have been, you know, for more than 4 years, but yet till today we are still discussing, and you know, it has a lot of brainstorming, you know, part of fun in that part. When we go to the field, you know, field means that we go and have a measurement of stratigraphics and stations. You see that the picture shows some pictures of where we have, you know, examined these sedimentary units, and where we have taken our measurements. So we started by, you know, for the students, it's very important to take as much as, you know, things that you can take with you when you go to the field, because you don't know which one you will be in demand or you want to use it, like a shovel, you know. Sometimes you are not thinking about the shovel or the lens or the camera, but you will need it in one of the things of when it comes to a certain unit that you need to describe. So the objective, as you can see, I have simplified it, me and Ayman, to the left side of the slide, that we need to describe the basics of the sedimentology, which is how is the shale, is it clay, is it sandstone, how it looks like, is it, you know, the basics that we take in the sedimentology. When we talk about the visible naked eye, when you looked at it, how you can describe it in terms of sedimentology of roundness or subangular, poorly sorted, the color, the physics, and so on and so forth. The second part of the work, which is the field work, you can see on the left side of the slide, where we have taken the samples. You know, the samples have been taken down from the wadi, you know, if we can call it wadi. This is where we consider it as a group that we decided that this to be the type locality of the exposed rock in Jal Az-Zor, where we can see from the base or the bottom of the wadi up to the top of the wadi. We have collected 18 samples. You can see the pictures of the 18 samples on the map. And the value of why we are taking this one, because the field at the end of the day, we are doing descriptive, measurable things, but we need something quantitative for the mineralogy, as well as to see under the thin section. You can see the two different samples. They are from the same formation, you know, but two different units. You can see how big stories you can tell. If someone who wants to do a PhD, he can take only the thin sections and focus on the diagenesis or type of transportation and so on and so forth. To the right side, you see the XRD data. The XRD data, it is one of the powerful data that we can use to identify the mineralogy of the content of each rock sample we can see. Because when you look at the sample in the field, you sometimes see all of them sometimes looks the same. But we will show you in the upcoming slides that two samples in the same location, they have two different mineralogy content, but they look from outside, same rock unit.
So here, basically, you could see we have shown you the study area. So basically, the study area is highlighted in the red box. However, we have looked at several areas highlighted by the red dots. These are scouted areas. We have analyzed them as well. However, in this talk, we will just focus on the red box and the main valley that is shown in here. Now, if you take a look at the fault itself, kinematics, we are describing it as a dextral strike slip fault. Of course, this has a vertical component to it. So in terms of structural geology, it's a transpressional fault. We have a compression combined with a strike slip. Now, here, what you can see here, we are looking at the surface map of Kuwait. And what we have displayed here, as you can see in the line, which is called basement fault vertical extension, these are, it's a projection, a vertical projection of the basement faults mapped from gravity and magnetic data. Previously, if you take a look at previous study, Carmen, for example, this fault was set in the middle of Kuwait Bay. So obviously at this point here, we don't see that fault, and later on we need to correct it. And we have a publication done in the Journal of Structural Geology, where we looked at the complex architecture of the kinetics of Jal Az-Zor, where we have found a lot of complex duplexes. So when I say duplexes, this means we have a train of faults that include thrusts as well as overturned faults. So it's quite complicated below the Jal Az-Zor. If you're interested, you could feel free to read the structured geology paper that we published last March. So here, basically, we could see that the escarpment is more or less situated at the fault plane. There has been some publications before that the Jal Az-Zor fault has eroded starting from the middle of the Kuwait Bay all the way to its present time. Obviously, the data that the newly acquired data does not support this information. So as we are concerned today, Jal Az-Zor is a fault escarpment that could have and has suffered from some erosion, which is normal, but it's not that where it has been eroded several kilometers away to the back. So here we have a view of the main wadi. We called it the Grand Canyon of Kuwait because it was one of the biggest valleys in Kuwait. And thanks for Dr. Mubarak for proposing that name. Unfortunately, and it's very sad, everything that you see now in this picture has been covered completely. So all of this is gone. So if you go there, you won't be able to see it because of the new construction going on. So the message here is we need to really expedite our studies, our sampling. So we will have a database, at least we can go back and study those rocks somehow. Otherwise, they could, in the near future, they could be lost. So looking at these outcrops, quite interesting, quite significant. And one thing, when you look at these, we can see very clear which is the cyclicity. So these cycles, they could represent parasequences, they could represent sequences, depositional sequences. At the time, we did not really know. Currently, we have done extensive work, so we are narrowing down. We have a publication that will come up maybe by early next year that will highlight the exact ages of these separate sequences. So this is the importance. But we wanted to have, to unlock the complexity by having a key, by key meaning the building blocks of these facies, so we can apply this building block to the various facies around Jal Az-Zor. So basically, at the end of the day, we will have a key to unlock any facies we go and see in the outcrop and develop the most common sequence in Kuwait and as in Jal Az-Zor. And as you can see here, this is the we have identified as one of the main sequences in Kuwait, the most common. Generally, if you go anywhere, most likely you're going to see something like this or something that will resemble it. And one key input, as you can see here, is the regressive nature of these sequences. So basically, we are talking about regressive cyclicity.
Excellent. So back again to the Grand Canyon, you know, so you see this is the location of the wadi, and it has a lot of distributaries, and this is one of the powerful, you know, let's say elements for this location area, because you can see at this side as well as you can see inside the distributaries. Yeah. Based on our study and the several visits that we have made, because you cannot decide from the first 2 visits that what you are going to do in this area. Based on that, we have chosen after all main stations, we can call them, or sub-traverses, because each one of these stations, it has like, you know, kind of a small traverse. And based on these stations, we said that we will make it from the bottom, where it is the lowest depth, if we want to take it in terms of elevation, the lowest elevation, up to the top of the wadi, where we can capture all the changes. We have started with the lowermost units. So these units till today, they are there. You can see here, again, Ayman as a scale and large scale of, cross-bedding at this part. After that, we moved like a 500 meter, the same fascias, which is this one, the reddish fascias. We will be talking about this in the upcoming slides. It is cutting, in a high angle, in another one of the, hard rocks, which is a calcareous sandstone at this part. It's cutting with an erosive surface at this part. And that's why we have chosen in the same location 2 types of, fascias that we need to cover. When we move a few feet upward, you can see at this section the fossiliferous sandy rock, which is comprised mainly of gastropods, and that's the drastic changes that we can see from just moving a few feet up to that section, how the stratigraphy is changing and why and based on what we are taking our stations. Above this one, to the left side, when you just walk a little of distance, you can see the next station, which is the 4th one here. It's around 4 meters of height, 4 or 5 meters. And again, Ayman, here is a scale. This lithology is totally different from the one is below at all, if you move from the bottom to the top. And also, I will show you the next station, how we are doing the field work, because we are moving across the wadi. This is the top unit there. So the next slide, which the one you see here as a zoom in, here is the hammer as a scale. You can see that this fascias is totally a massive structureless fascias. You cannot see any cross bedding. You cannot see clear bedding structure inside these fascias. But when you move upward to that unit, which is zoomed in here, you will see a different fascias, totally different nature in terms of contacts, erosional basal boundaries. All the fascias are different, and Ayman will be speaking about that in the upcoming slides. The main unit here, you can see Dr. Mubarak here is a scale. This is one of the next stations, which is stratigraphically, it's located above this one, but on the other side. If you move into the wadi and you take the stratigraphic positioning, this unit, it comes above this unit. And the last one, when we move inside the deepest part of the wadi, which is after that, you go at the top where you find, people camping and so on at the top of the wadi. So this is a view here. You can see where we moved from, that dot there. There is small traverses there up to that point, which is a total of around, 35 to 40 meters of thickness that is really in need of a future plan from you, staff members, as well as the students. Those are thinking about master degrees as well as for the future PhDs as well. There's a lot of work can be done, and this is just a glance of today. What is the work that we have done and what we are planning to do as a methodology. So the field observation, when we talk about the field observation, we are talking about what we can see at the rock location, when we go to this one, it is like the doctor when he is examining the patient, you are looking to each piece of that you are looking to and what it can be representing. So at the beginning you describe, and then you go and discuss with the colleagues, because at first visits, you will see 2 different things. So the measurements is the first one. We do measurements for these thicknesses, how the thickness looks like. If there is a cross beds or any kind of bedding that should be measured, that's why we call it measurement. After that, we move to the sedimentary structures. So the sedimentary structures, those are all the sedimentary structures in your background. If you don't know something that you have seen at the field, there are thousands of publications about these kind of features which you can be suspicious about. Plus, you have your doctor at the university. These are the first spot where you can discuss with. So what are the observations? We observe, first of all, the texture. Is it gravel? Is it sand? Is it silt? Is it clay, etc.? Then we go to the bedding. Is it bedded, not bedded, cross-bedded, dribbles, and so on and so forth. We go to the ichnofacies. Look to this picture. It shows different ichnofacies, from intensively ichnofacies, because the ichnofacies intensity can be also an indicator of how is the environment and the climate and the conditions where these organisms have been living at the time of the deposition of this rock. After that, we are talking about the contacts. Look at the contacts for these two pictures. When you have a contact that is followed by a gravel, that gives you an indication of how is the event after the deposition of this final grain has been changed drastically. So is that related to a change in the whole environment of the deposition in the whole area, like a season of very strong rain, or it is related to a tectonic event? So all of these questions will come up with your observation. That's why we call them field observation. Look to the contacts here. The lower unit, it is one of the units that it is, kind of irregular shapes, followed by sharp changes in both the cross-bedding texture that has no bioturbation inside. After that, we describe the color. The color is very important. We take a sample, we try to take a fresh sample. It is not the sample that is exposed at the top. I am sure 100% when you go to the field that the instructors, they teach you that you have the way you take the samples and the way you describe it instead of taking a contaminated sample from the surface. So we move forward to the lab observation. We spoke about the field, what we are doing in terms of measurements, in terms of sedimentary structures, and in terms of the physical measurement, which is related to the color as well as to the hardness and HCl, because we do HCl as well to see how much of reaction in the rock related to the calcium carbonate, if it is in there. Look at this exposure. You can see this rock unit. It is one rock unit from the base here up to here. You can see it is only one rock unit. If we zoom in into this rock unit, you see that this is the stick, which is around ½ meter. So we are talking about 1.5 meter all of this section. If we take a sample from this one, you can see how is the sample is poorly sorted. You can see also small pieces of clay materials inside this sample. But if you take another sample at the top there, it is totally different. If you do description at the field, this is where we say that the data is complementing each other. The field observation, you will say that I have a medium sorting here. It is a white. It shows some quartz or calcite because of the HCl. It shows a medium reaction. So you put your remarks in the field. It has big quartz grains, subangular to poorly sorted. But it has a very strong reaction in calcium with the HCl. It shows a content of calcium carbonate. This is when it comes to the field description, because you can see also here there is a contact or a surface of a contact that fill in with these conglomeratic or pimply fascias that is overlain by these clean units. So where is the complementation? It comes from the lab observation. You see this thin section and the lower unit, they are totally different. So this thin section, it shows a dominant of quartz, with a little bit of calcium carbonate and a little bit of micrite fill in as a cement. But most of the rock is, a porous with intergranular porosity inside. The next one, it shows seriously poorly sorted, because and we are lucky in this thin section, by the way. If you need to take a thin section in such kind of a rock, you are lucky to get a thin section, because you see the right hand side and the left hand side of the thin section, it's totally different. Plus, we can see that the calcium carbonate is coming in, which is as a calcite cement here and a calcite crystals in between. These observation for the future studies, they can be like a fat material for students to go and dig into these petrographical observation for the diagenesis and source of sediments. And here when it comes the XRD as well. So in this slide we show you the comprehensive observation from the field to the sample that we take, to the description we do in the field, to the thin section, as well as to the XRD data. So the XRD data is very valuable data. It's coincide and in agreement. Also, we are lucky with the description that we do with using the simple tools like HCl at the field location. Ayman, you are muted, Ayman.
So here we have a simplified complex, a simplified sequence that represents the building blocks of the Jal Az-Zor sequence. So here what we are highlighting is, or what we are raising the questions, what could these deposited be? For example, the lower section, the highly bioturbated, in what deposition environment could this be deposited? The muddy facies with no bioturbation, in which settings is this deposited? So we will go one by one, and hopefully we're going to see how we reach to the end of the story. So basically here we could see we have a highly intensive bioturbated section. If you go there to Jal Az-Zor, this is the first thing that will appear to you. Now, there has been a lot of discussions on this. Are they bioturbation, or is it roots or mangrove roots? So we have, as a team, we have been through this discussion, and we came to a conclusion based on the evidence, and I'm going to show you some of those evidence that these are bioturbation. So here we have highly intensive bioturbated. What we have done here, we managed to recognize what type of ichnofacies are they. For example, in these sections, we could see a significant amount of sclerosis. We see thericenoites. We also see ophiomorpha with the pellets, and I'm going to show you some textbook examples down the line here. Here we could see the burrows that are filled with red clay material from the overlaying deposits that we will show you later on. All of these indicate that these are bioturbation. We have also taken thin sections in those sections and in those areas along these bioturbation to see if there's any carbonaceous material. Is it roots or bioturbation on the micro scale? And we have determined on the micro scale these are very consistent with bioturbation, and this is where we conclude from the microscopic point of view. This facies also contain some conglomeratic trough crossbedding lens-like deposits. So this also corresponds to fluvial, but the question is, how could we have this body embedded within a highly bioturbated section that is predominantly conglomeratic in nature? As well, if you take a look at the lower contact as well, we can see here we have an erosional contact. So the base is clearly scoured. We see a lot of lateral accretion surfaces going on, trough crossbedding, indication of fluvial. However, it's augmented with a massive presence of bioturbation. So this is how we represent these facies. We have called them here F1 and F2, and we have also taken some polycurrent measurements. Now, if you're in the field, especially if you're measuring trough crossbedding, you need to be very careful, because from its name, you can see you have a large scatter of crossbeds. So you need to make sure you analyze the outcrop in 3D, hopefully, to get the proper current direction. And you need to differentiate between the trough crossbedding and the lateral accretion surfaces, because the lateral accretion surface dip is perpendicular to the current direction. So when you go to the field, you need to have this knowledge in your pocket so it can help you when you see these features in the outcrop and you do your measurements. Because if you lump sum all of these crossbed direction, you will end up either not understanding them or having to do a wrong interpretation. So this is the famous ophiomorpha that we have here in the area. We could see here on the side, we have a zoom in, and the ophiomorpha burrows is characterized by the pellets. So if you take a closer look, you will see these these small oval shapes that represents either fecal matter or the liquids of the shrimp in this case, most likely, where it packs the surface to make it stable. And we can also have an indication on the energy level by looking at the wall of these ophiomorphoboros. So these are textbook examples. Now, if we go take a look at this section, we have very clearly a burrow that is quite vertical, but again, we have another body on the side. So basically, this is the living chamber. So let me highlight this for you. We could see here where the shrimp or the crab was living in this living chamber, and it has different escape routes. So basically, what I'm trying to say, and here we have a model. So basically, you have an ophiomorphoburrow with living chambers. We pour in some cement, so we develop a cast of this burrow. So basically, in this case, there is no way such features could be roots. If you keep looking, you will actually find these evidence, and this is where we managed to reach to our conclusions. So the next facies is quite muddy facies. They are red facies, quite tight deposits. We have ripples. The thickness is more or less 1.5 meters. It has scouring surfaces as well. And what we have done here, we have taken the orientation of these scouring surfaces. So sometimes we cannot take the eddy current direction from the troughs, but what we can do, we can take the channel axis. And this combined with all this information can help us identify where is the direction of deposition. So the next unit here is the cliff forming unit that Ali was showing earlier. So it's calcareous sands, reacts with calcium, with the HCl. There is a lot of scouring surfaces in the bulk part, poorly sorted in some places, well sorted in others. There's a lot of erosion and lateral variations within the thicknesses, and it also gets eroded by other facies. For example, here we see this channel-like feature with lag deposits, with pundles over there, and if you take a closer look, we start to see some burrows which are described as sclerosis. So this is a representation. The XRD data shows that we have around 35% calcite, so it's still clastics with quartz with some 40%, some clay material, but it is very well cemented, and that's why it's forming the cliffs. Now here we have another unit which is forming towards the top. It's easily eroded. We don't see it everywhere. It's also coursing upward, and we have represented it with this section in the area, and we will see where this fits into the whole story later on. So this is where it gets interesting, the F4 facies. You can see here at the top, there is a ½ meter white layer, and this white layer generally caps all of the sequences that we see in Jal Az-Zor. Now, you need to keep in mind that these facies are easily eroded. So if they are not there, most likely they are eroded. And they're incorporated into the overlaying sediment. So you can see some evidence of reworking in the next cycle. So if you take a closer look at these layers, they are predominantly composed of carbonate. Here we can see evidence of fenestral porosity. And basically what we describe these is as microbialites. Now we know that these have been described as caliche or as calcrete. However, we have done extensive work, and we have a paper that hopefully we are writing currently and will get published in one of the international journals, where we have done a lot of detailed work and we have concluded that these layers here that we see here are basically microbialites. In the paper that Ali will share with you and Dathir will share with you later, we can see these are described as thrombolites. So if you're interested, you could go and read that and read more about thrombolites and microbialites that have been identified in Jal Az-Zor. Next, Ali. So here we can see that we have this, we have the layer, and it's underlain by a greenish yellowish clay layer. Basically, we have identified through XRF that the green color is because of neimite mineral that's giving us the green in color here. And these are more or less assumed as overbank deposits. Now, the next facies here, we show here trough cross bedding, well sorted, but again, very coarse conglomeratic with no bioturbation. F9 facies. And they normally occur above these microbialites. They have erosional base, and they are normally eroded by the overlaying sequence in the top. Next.
Yes. So as you see that Ayman, there is an echo. Maybe someone has to. Can you mute Ayman? Yeah, maybe now it's fine. Yes. So Ayman has shown you, through the succession and the fascias that we have observed through the area, So what we have seen is facies and, variants from the northern eastern part here in Sabria, we call it Sabria road cut in this section, up to the south western part of the area, which is the main location here. So the dominant of the stratigraphic section that we have observed and we will be observing is from the main wadi, but also we have taken some locations along this outer group. You see all of these sedimentary structures, observed features we have documented, and these are, what we see as the optimum work that can be done for the time being in reporting these facies that are representative. And we are pretty sure that these facies will be extended for further studies, because we are looking forward for another alternatives for this interpretation, But for documentation of the sedimentary structures, also, there is a big chance of having, more research about these facies. So we see all of these facies, they are documented in one paper we will be sharing with you. The Ayman that shown all of, or most of them in terms of Ichnofacies to sedimentary structure as well as to the stratigraphic architecture. So all of this work was integrated in, at the end of the day, as we stated at the beginning, in one stratigraphic, understanding. So how we will build our stratigraphy is by going by facies association, how these fascias can be associated at one time together. If you see now, and you just go to the Google Earth map, and you see along the coastal line of the Arabian area from Kuwait to Abu Dhabi, even inside Kuwait, from the southern part to the northern part, you see huge variance in terms of the sedimentation from Bobian Island to Khairan area. It is totally different because the kinematics and the process is totally different. There you will see a lot of waves action with a lot of sandy grain deposited, while in the northern part in Bobian, the impact it will be with a rich of muddy tidal environment that has a total also different Ichnofacies that is located in the southern part. So we came up with the 9 facies. Okay, those can be collocated and combined in 6 facies association complex that is varying within the same context of marginal marine depositional area up to the terrestrial fluvial setting.
Okay, so here we could see the sequence from bottom to top. We have the famous or very well recognized red layers at the base. These grade upward into more grayer sediments, and then we have the cliff forming unit and the cycles that we have illustrated here. One of the major boundaries that has been recognized in the area is the one highlighted in red. It separates the sequence below and the one above, though we will highlight the significance of this boundary later on in future publications. However, what we can see here is the cyclicity of the microbialites. The relative sea level curve here that we have developed shows a drop in sea level every time we reach these microbialitic layer, in highlighting the regressive nature. We can merge these into three main large cycles, depositional cycles. And you could see we are going from tidal complexes to barrier island complexes to estuary complexes with the injection of minor terrestrial fluvial facies. Now, in this area, we don't have a lot of fluvial influence. However, if you go to the northwest, and in the subsurface, this is where the fluvial influence increases, especially towards the subsurface, where we are moving away from the shoreline. So the depositional model that we have developed looks at a profile from land to the sea. We could see here the three different sequences that we represent here. If you don't have the right knowledge, it will be very difficult to make sense or correlate these facies, and this is where we have developed the stratigraphic facies architecture to make it simple for us and for the reader to really understand the lateral facies. Now, the grand slam of this work is the depositional model. We could see here we have our northwest-southeast trending shoreline. We have our northeast-southwest trending fluvial channel and estuary system, showing the interaction between each different facies in space and following the Walther's law that you have studied in Geology 101.
Yeah, it worth to mention, Ayman, that the importance of this architecture for the subsurface. You know, it's very important because what we have seen in some subsurface publication from the core description later after this one, it shows that there is also some core studied in the north that they are penetrating the same architecture, which is give us an idea about how even the older sediments, those are in the subsurface, they are repeated and repeated again and again. So this is very important that to match what we see on the surface with the subsurface in the future as well.
Absolutely.
Yeah.
So basically, coming back to one of our first slides in the beginning, from our strontium isotope publication. So what do we think the age is? So this is what we believe in our strontium publication with Dr. Mubarak al-Hajri. From the data we have from surface combined with well data in the subsurface, we have identified that the Kuwait Formation, what we call Kuwait Formation, previously known as Kuwait Group, extends all the way to the late Eocene. So we have evidence that the formation extends to the late Eocene. And this really makes the Dammam middle Eocene as well. So it pushes the Dammam to an older age. We need to think in terms of these facies, the Dibdiba, Lower Faris, Ghar. Today, no one can put their finger on what is the real differences between these formations. Gregory in 1929, he identified them as undifferentiated tripod subdivision that needs more detail. If you go to Iraq, if you go to Iran, if you go to especially towards the north, these are quite differentiated because Lower Faris is carbonate, is evaporitic. Ghar is a different a sandstone facies. Dibdiba is more conglomeratic. If we come to Kuwait, we don't see that. So what we believe that it should, this is a different character from what we see in neighboring Saudi, neighboring Iraq, and neighboring Iran. And I think it's time to step up and start making the changes in the geological nomenclature. Iraq has done it. They have removed the lower Fares from their nomenclature, and I think Kuwait as well. It's time for it to step up and revamp its Neogene, Paleogene stratigraphy. So the question is, where did these sediments come from? We have done some XRF analysis, and as you can see from the zircon titanium plot, we have identified a region where we could see some patterns here. If we compare it to previous publications done in Arabian Shield, we can identify that these sediments have came from an area called Derbez Beida along the Arabian Shield ophiolite complexes. Now, the mechanism of transportation, it happened through Wadi Hafr al-Batin, which has pre-existed before the tertiary. So this is a vehicle that allowed all of these sediments to come and erode and deposit within Kuwait. So in conclusion, this is where we started. And if we take a look at the development that we have done recently, thanks to the team of passionate geologists, we managed to identify the various depositional sequences, the various deposition model, the architecture, the complex details from the scale of macro to micro scale, giving a facelift surgery to Kuwait. And the hunt is on. We are still trying to study different aspects of the Jal Az-Zor, and we look forward for your work, for your contribution to the geology of Kuwait. Thank you very much.
Thank you, Ayman. So at the end, we would like to thank everyone who has directly and indirectly contributed to this work. This work is not an individual work. Of course, it has a lot of contribution, thoughts, ideas, brainstorming coming from everywhere. You can see in the picture that KOC field trip last 2 years, and one of our trips with the Kuwait University as well as Shell. Those are working in the heavy oil work. They have published also another good work for the subsurface, and they are also trying to understand the surface as well. By having said that, I would like to thank you. Thanks, Ayman. Thanks all the audience, attendees, for having us today to present for you. Sorry for taking 1 hour almost from your time, and hope that this is a valuable information for you that we can share later.